honored to introduce Jim Hansen, our Chafee Memorial Lecturer. I'm going to ask Richard Benedict to come to the stage. Richard is the founding president of the National Council for Science and the Environment. He is an ambassador, the U.S. chief negotiator of the Montreal Protocol. And while climate change is a much more challenging issue than the stratospheric ozone issue, the approach and the success of the Montreal Protocol in addressing that issue is exactly the kind of thing that we need to be striving for. Much harder to achieve, will take much longer to get to, but that must be our aspiration. So I'm going to ask Richard if you'll come to the stage, and if you'll introduce our Chafee lecturer. Thank you.
Thank you very much, Peter. Well, it's another year has gone by, and I'm happy to see so many eager, intelligent, and also happy, I hope, people coming to our conference. Peter has been a wonderful director of our programs, of our small but I think very strong but well motivated organization which has really made a name for itself in the course of the last 20 years. I have the honor tonight and the privilege of introducing to you formally a true warrior for the future of planet Earth, a brilliant scientist, a courageous advocate for free speech, and for me personally, a friend and a mentor. Ladies and gentlemen, Dr. James Hansen has been for many years one of the outstanding scientists who have been warning the public and the politicians of the dangers of climate change. For years, he has been producing articles, giving lectures, reaching out to students, to industry, and to non-governmental organizations, and to citizens in general. There was a time a few years ago when people tried to mute his efforts. They tried to silence him. They tried to force him to leave his post at NASA, the National, at NASA. Sorry about that. They tried to stifle his publications, but Jim didn't let them do this. Every few weeks, I received in my email box another article by Jim Hansen on the dangers of climate change and what we could be doing about it to help to prevent these dangers. And I'm sure that it was not only me, but there are probably dozens of others, of scientists, of teachers, of NGO, non-government organization people, and of course, I would bet, of politicians. They tried to stifle him, but they did not succeed. And his articles still keep coming in my email, and they refresh me both for his courage and also for the insights that he is giving, the warnings that he is giving that need to be accepted and acted on by a population of people like yourself and by our political leaders. They have not stifled him, and therefore I am particularly proud, in the name of the National Council for Science and the Environment, to present Jim with this annual award, which is given in memory of another courageous fighter for truth and for science, and that is John H. Chafee, the former senator. Each year we present this to someone who is acting and giving of his own talents and of his own professional development, giving power and courage to those of us who want to continue to do the work of protecting our planet from all sides, but in this case especially from climate change, which would be a true apocalypse, which would affect people over the entire planet. It is my pleasure to do this, And I have the other. This is what I have for you. Thank you so much.
When I came in the room, can you hear me? When I came in the room and saw those guys sitting up here, I thought, oh no, I'm back in the government. But actually, those guys deserve enormous amount of credit for what was really a golden era of collecting global data and trying to understand global system. It was a golden era. In fact, Shelby Tilford had on his desk a sign that said, "The golden rule, he who has the gold rules." and he dispersed that gold very carefully, but and very effectively, I think. Okay. Now, somehow or other, it seems that whenever I give a talk on global warming, it's very cold. This is, and you notice, actually, if you look at last year, 2013, it was quite warm over the whole planet. But then if you look at December, it was up to 5.5 degrees Celsius colder than the 1950 to 1980 average in North America. And in Siberia, it was up to almost 10 degrees Celsius warmer than the 1950 to 1980 average. And of course, this variability in the winter is not a surprise. It's one reason why we focus first on looking at the summer, also because the warming effect is more important in the summer in the sense of having impacts. But if you look at the standard deviation of a surface temperature, of the summer mean, 3-month mean temperature, it's only between 0.5 degree and 1 degree Celsius over land areas in the northern hemisphere in June, July, August. But if you look in the winter, it's like 2.5 or 3 degrees. So it's about 5 times larger in the winter than in the summer. So as a result, if you look at individual years, these are the last 9 years, and this is the winter, or December, January, February temperature anomalies relative to 1951 to 1980. And you can see there's some fairly substantial regions, or almost always, that are colder than the 1950 to 1980 temperature. But if you look in the summer, June, July, August, they're in the northern hemisphere. You see there are very few cases. Well, 2009, North America was a little cooler than the 50 to 80. So that's so it's not surprising that in the winter you will find anomalies someplace on the planet. That was why actually in 1988 I immediately, after saying that the warming was related to human effects, I decided I had to make these dice, because the standard deviation, the warming, is 0.8 of a degree averaged over the planet relative to 1880s, but nobody remembers how cold it was in the 1880s. So we do, some of us, I guess all of us, all the guys on the stage and me are old enough to remember what it was like in 1950 to 1980. And since then, the warming has been 0.6 of a degree. Well, if the standard deviation is a few times larger than that, then of course sometimes it's going to be cold. It's going to seem cold. But the probability distribution, the bell curve that describes this variability is shifting. And if you look at it decade by decade, you can see that it is shifting. And even though we still get some times that seemed cold, even in 1950 to 1980, that's the blue region, we still get some of that, even in the summer. But, and the unit here on the x-axis is standard deviations. So if we converted it to temperature, then the winter bell curve would be much broader. But you notice that the summer is shifted more than the winter. But still, the dice are loaded in the winter also. So the chances of having warmer than normal are greater in the summer, but are also greater in the winter. It's also interesting to look at the seasonal mean temperature. This is over land areas. So the graph on the left, the blue is the December, January, February, so the winter season in the northern hemisphere, and the red is the summer. And you see there's been no slowdown in the warming in the summer. But the last decade, the winter temperatures have decreased somewhat relative to the peak several years ago. And that's related to the temperatures in the Pacific Ocean. Here we have decade by decade these temperature anomalies, and you can see each decade has been getting warmer. But then the last graph, the one on the lower right, is the last 3 years, the first 3 years of this decade. And it's about the same as the last decade, within 1/100th of a degree on the global average. It's actually warmer over the land areas, but the Pacific Ocean, the eastern Pacific, has been relatively cool, and that's what affects the winter temperature. In the summer, when the temperature gradients from equator to pole are much less, then the land is basically responding on its own without much influence from the ocean. But in the winter, there's a huge influence of the ocean as the winds are much stronger and you have dynamical effects. Although people now argue that, well, the warming stopped in the last decade, it has been relatively flat, but in fact that's related to the ENSO variation in the tropics, which are shown by this Niño index on the bottom. If you look at the blue valleys are La Niñas, when the Pacific, eastern Pacific, is relatively cool, and the maxima are the El Niños. But if you look at the successive La Niñas, you'll see that each one of them has been warmer over the last couple of decades. And the successive El Niños, each one has been warmer, even though the 1998 El Niño was much stronger than the more recent ones. But despite that, the recent ones have been warmer. So in fact, when you take an 11-year running mean, as done on the right, the temperature, global temperature, is still going up, and we know that it's going to keep going up. How do we know that? Because we now have measurements, and by the way, NOAA deserves a lot of credit for pushing the system, the global system, to have more than 3,000 Argo floats distributed around the world's ocean, which dive down to a depth of 2 kilometers and make measurements, including the temperature. And that allows us to measure the planet's energy balance, because the atmosphere has very low, small heat capacity. So most of the energy imbalance is going to have to be represented by the changes in the ocean temperature. And we can now measure that accurately enough to get the planet's energy balance. And what we find is that the heat content of the ocean is increasing. And this graph is not quite updated, but the several years after that also continued to go up. So the planet is out of energy balance with more energy coming in than going out. So in that sense, it's continuing to warm. And of course, the surface, if you sample at just one level, there's more variability, but the surface is going to continue to get warmer because the planet is out of energy balance. Now, I was supposed to talk about the minimizing the impacts, the irreversible impacts of this climate change. And I think the two that deserve special attention are sea level, because if ice sheets disintegrate, it takes thousands of years for ice sheets to build up. So if we cause them to disintegrate, then it's going to be an irreversible effect on any time scale that people would care about. And likewise, if we drive species to extermination, then that's also irreversible. Not that the other climate effects are not important. They are important already, and they'll be more important in the future. But these irreversible things deserve special attention. Sea level, its rate of increase is growing. It's now 3.2 millimeters a year, which is about 14 inches in a century, which is already significant, but the danger is it could be much larger than that, because we know that during the last interglacial period, the last time it was warmer than the current interglacial was the Eemian, when it was about 2 degrees Celsius warmer than pre-industrial, which means about 1.2 degrees warmer than at present. Sea level was at least 5 meters higher, and probably 6 to 8 meters higher at its highest than it is today. And that's so 2 degrees Celsius as a target for the maximum warming is actually a dangerous target. We may not get large sea level rise within decades, but on some time scale we would be setting up the planet for a very large change. And unfortunately, the paleoclimate record does not contain any examples in which the atmospheric composition changed as rapidly as we're changing it. Even in the most extreme case, the Paleocene-Eocene thermal maximum, which looks like a spike on the paleoclimate records, but the gases changed, the rate of change was more than 10 times slower than what we're doing now. But so we can look at what's happening, and we can see that the area on Greenland that's melting is increasing. That meltwater will burrow a hole in the ice sheet and speed up the discharge of icebergs to the ocean. Probably the most important effect is actually the warming of the ocean, because that's melting the ice shelves, the tongues of ice that come out from the ice sheets into the ocean. And once those ice shelves are gone, that allows the ice sheet to discharge ice to the ocean much more rapidly. And now one of the really spectacular measurements that we have is the gravity satellite, which measures the gravitational field of the Earth so precisely that we can see the changes in the mass of the ice sheet and the Antarctic ice sheet. And there's a seasonal cycle, of course, as the ice sheets get heavier in the winter and then lose mass during the melting season. But overall, they're losing mass. Greenland now losing more than 500 cubic kilometers of ice per year. And the rate, although the record is still short, the satellite record only goes back to about 10 years, but there's already evidence that that rate of mass loss is accelerating. In fact, if you go back a couple of decades, it was probably close to mass balance. It's only in the last 2 decades that it's begun losing mass, and that rate is increasing. The other, and I think that's that sea level issue is one that deserves a lot of attention, and there's still large uncertainties about how rapidly things can change over the next several decades or even this century. But there's the danger that we're setting up a situation which will then be out of control of young people and future generations if we don't slow down and stop the change in the atmospheric composition. But the other thing that's irreversible is extermination of species, which is, scientists euphemistically describe it as reduction in biological diversity. But what it means is you exterminate species which are then gone forever. And the problem now for most species is more related to other things that humans are doing. We're putting stresses on different species in many different ways, as indicated here. But when that becomes in combination with a large, rapid shift of climate zones, that is potentially could drive a large fraction of the species on the planet to extinction. We know that there are some cases in the Earth's history when a significant fraction of the species were driven to extinction by climate change, but this change is much faster. As I said, it's more than a factor of 10 faster than during the PETM, the Paleocene-Eocene thermal maximum. So it's potentially very dangerous. And I like to use this butterfly as an example of how this works. Several years ago, I started planting milkweeds with my grandchildren because the monarch butterfly is now threatened by herbicides, Roundup in particular, because that kills milkweeds, which is the only thing that the monarch caterpillar larva can eat. And so we started planting these milkweeds, and I've noticed that the number of monarchs has gone down by an order of magnitude. It used to be we could see 10, when my wife and I were young, we could see 10 or 12 butterflies on our property at the same time. Now you're lucky if you see one. And there's so few that sometimes you can identify one, and in the case of this one, it was easy to identify this broken wing female monarch, and for a few weeks she was the only butterfly in our backyard, and she decided she wasn't going to go any further. We had milkweeds for her, and we had these butterfly bush. And even though that was a summer in which, that was 2011, when we had there was a storm that came through Washington up to Pennsylvania where we live. There was a rainfall which was more than 6 inches. Our rain gauge overflowed at 6 inches. But when I came back from Washington after being down here several days, I found that butterfly was still flying around in our backyard. And by that time, she had produced about 25 of these larvae, which then eventually produced the chrysalises in our hedge. And from that, at the same moment, actually, 2 of them burst out with these monarchs, one of which was, here's a male, and the other one was a female. But we were wondering how many of these monarchs would make it to Mexico. I'm sure most of you know the story about the monarchs. Monarchs actually are a remarkable insect. They fly from central Canada all the way down to the middle of Mexico and hibernate in Mexico in a small area in a mountainous region in Mexico. And it takes 3 or 4 generations for them to make that round trip. But so the ones that would be born in our yard in Pennsylvania would actually most of them would try to make the trip all the way to Mexico. So that's remarkable how far these butterflies can fly. But they had to go through Texas, and there was a huge drought. Well, so we wondered how many would get through. Well, a lot of them did get through. This was a picture taken that winter on one of these fir trees on the mountain in Mexico. It was taken by a Mexican scientist who read an article I wrote about the monarchs. And this was his son looking up at those butterflies. But what they noticed was that the trees were not doing very well because of the drought, which has been persistent in the Southwest and in Mexico for the last several years. And so he was trying to persuade the Mexican government to plant some of these trees higher up in the mountain where they would have a better chance of surviving with the warming climate. But he also calculated that by the end of the century, if we follow business as usual, the mountain actually wouldn't be high enough given the temperature change that was expected. But now, so that it turned out that winter, the number of monarchs was reduced 30%. The next year, 2012, there was a drought throughout the whole Midwest, very strong drought, and the number of monarchs that made it was reduced another several tens of percent. And then this year, I didn't notice. We only saw one monarch the whole summer in our backyard, and that monarch, monarchs made me wonder, because it turned out I was wondering why this monarch wouldn't go over to these milkweeds that we had planted and lay some eggs on them. Well, it turned out after I took a photo that I realized this was a male, so it wasn't going to lay any eggs anyway. But that monarch stayed around for at least a couple hours. He flew all around the yard, landed on the grass several places, landed in the privet hedge, came to the butterfly bush, and then he eventually got chased away by these big yellow tiger. I always forget the name of it. Swallowtail, tiger swallowtails. But so I thought, well, gee, how these monarchs are not like the birds that travel in pairs. They don't. So what is the chance? I think the chance now that the population has been reduced so far, I think there's a danger that the population has passed a tipping point where they don't have enough encounters between the males and females in order to reproduce. But that's a hypothesis. But I think we're getting close to the danger that we're exterminating this particular species. There are a lot of other species. There's more than 1 million species associated with coral reefs. And these are threatened because not only the warming of the ocean, which causes the coral to, in the case of it, when you get extreme warming, they will expel the symbiotic algae and the coral can die, but also the acidification of the ocean. So we're losing more than 1% of the coral per year. So there's a danger that we could exterminate a huge number of species if we keep going down this path of both climate change and acidification of the ocean. So what's clear is that we can't burn all of these fossil fuels. We've only burned the purple parts of oil, gas, and coal. But there's a tremendous amount of coal left in the ground, and there's also unconventional oil and gas, the tar sands, the tar shale, the fracking to get gas. And unfortunately, our governments are not only allowing the exploitation of all of these fuels, but they're encouraging it and even subsidizing it. And it just doesn't make sense. It's not consistent with the science. And we tried to quantify this in a paper that we published a couple of months ago. A paper which actually we had submitted to PNAS, but the editorial board insisted that we take out normative statements in the paper. So we decided we didn't want to take them out, so we published it in a different journal. But what we concluded was, we've burned so far 370 gigatons of carbon in the fossil fuels, and that's really what counts. The deforestation is important also, but that can potentially be put back into the forests and soil. But the fossil fuel carbon is the problem. And if we wanted to stay close to the Holocene, and that's what we argue we should be trying to do, then we would have to limit fossil fuel burning to 500 gigatons of carbon. Well, in order to meet that target, you'd have to start reducing fossil fuel emissions 6% a year, which people say is not possible and that not practical given the infrastructure that we have. And that's probably true, but that doesn't mean we have to go to 1,000 gigatons of carbon. If you reduced emissions 3% a year, you could keep the warming 1.5 degrees as opposed to 2 degrees. If you set a target of 1,000 gigatons of carbon, then that guarantees that you're going to get slow feedbacks. The 1,000 gigatons of carbon will give you a warming of at least 2 degrees Celsius. But then, if you get that much warming, you're going to bring into play slow feedbacks because the ice sheets will get smaller. The greenhouse gas releases from the ocean and from the tundra are going to magnify that effect. So it's possible to stabilize climate, but it's going to require phasing out coal. And it's going to require leaving most of the unconventional fossil fuels in the ground. But this has not sunk in to the political system. Instead, we're actually accelerating our rates of emissions of fossil fuels. The problem is that as long as fossil fuels appear to be the cheapest energy, then we will keep burning them. But they're not really cheapest. Because they don't pay their cost to society. The human health effects of air and water pollution from the fossil fuels are borne entirely by the public. If your child gets asthma, you have to pay the bill, not the fossil fuel company. And the climate effects are also borne by the public or by the governments, which is the public. So we need to add a tax or a fee which you collect from fossil fuel companies. And it should be collected at the mine or ports of entry so it's across the board and covers all oil, gas, and coal. And I argue that none of that money should go to the government. It should all go to the public, an equal amount to every legal resident. And that way the person who does better than average will make money. But we will be moving the technology, and we'll be moving the economy, we'll be moving people's choices to minimize fossil fuel use, because people would prefer to not, to minimize their cost and maximize their gain. And this, economists agree that this is the way you should deal with the problem. Rather than regulations, make the fossil fuels pay their costs. That would stimulate the economy, and this is the one viable approach for an international agreement, because if just China and the United States would agree to have a carbon tax or carbon fee, then they can put a border duty on products from countries that don't have a carbon fee, and that would be an enormous incentive for other countries to have their equivalent carbon fee so they can collect the money themselves rather than have us collect it at our borders. That's the objective of Citizens Climate Lobby, which is now has been almost doubling in size each year for the last few years. They write op-eds, letters to the editor, and they visit their congressman, and they are always very polite and respectful. And if the congressman won't see them, so they have to just speak to the staffer, they do that, and they come back again the next year or at a later time. And I think this has a chance of influencing the politics, so we can finally put a price on carbon in a way that would actually work. This quantifies their letters and visits which are growing rapidly. And this is a matter of intergenerational justice. Or potentially injustice, because our parents did not know that by burning fossil fuels they were going to harm future generations, but we can only pretend that we don't know. We can also, one of the things I can do then out of the government is sue the government, and we're making some progress on some of these cases. However, the crucially important thing is getting a fee on carbon. And so I encourage anybody who has time, now that you're retired, Bob, everybody, join Citizens Climate Lobby and put some pressure on our government to do what is needed for young people and future generations. Thanks. Is there going to be Q&A? Oh, okay. Thanks.
Jim has agreed to take a few questions. So I'm going to pick up on something in here and something I just heard from the audience. So this is a fantasy I want you to go along with for a second. Tomorrow, Vice President Biden steps down and you're becoming the Vice President. Friday, Obama decides he can't take it anymore and you're elevated. So Saturday morning, you're sitting in the Oval Office. The Congress hasn't changed. Public opinion hasn't changed. But suddenly you have authority to do certain things, executive orders and so forth. What are the first three things that you would do?
You know, I'm not a Democrat and I'm not a Republican. I'm a political independent. But I think that, the problem that we have politically is the conservatives believe that climate change is a mechanism that liberals have for trying to get more control over society, I can understand their perspective on that. I have spoken with conservatives. Well, actually, I come from western Iowa, and I'll tell you, that's the red end of Iowa. Iowa's a purple state, but that's because it's got some cities and universities in the eastern part, but the western part is conservative. So I understand conservative philosophy, and there are lots of parts of it that I agree with. And I had breakfast and lunch with Grover Norquist, well-known conservative, opposes tax increases. And he's a very intelligent guy. And I think that he is an example, and I think conservatives understand that if they argue that climate change is a hoax, this is all made up, that they realize that eventually when Mother Nature makes it clear that it's not a hoax, then the public will expect the government to do something about it, and then what the conservatives fear will happen. The government will take more control of their lives and increase taxes and do things to try to deal with climate change. So conservatives can support a conservative approach, one that lets the market make the decisions rather than And so what you would do if you were in a position of authority. I wrote a letter to Obama when he was elected, but I couldn't get it delivered to him. I mean, you could put it in the mail, but but you have to sit down with conservatives and you have to explain to the public what the story is, and it's going to require that fossil fuels will become more expensive. But if it's done in a gradual fashion, and if the money goes to the public so they can deal with the matter and make choices as that's gradually rising, they'll choose different vehicles the next time they have to replace a vehicle and make other decisions. So, I mean, I think it could be done. I don't think you can do it with regulations. Yeah, I mean, it's nice to take steps to increase efficiency of vehicles and things. That's useful, but we really need this underlying drive across the board. Otherwise, you save some fuel one place, it just makes it less precious. So then it will be cheap enough to be used for some other purpose. If we're actually going to leave the stuff in the ground, the only way that can happen is if we have a rising price that's going to continue to go up, and the public will never allow it to go up if the money is going into the coffers of the government to make the government bigger. And that's what conservatives don't like, and I don't blame them.
Thank you. Now, this next one, I think, flows naturally in some respects. Your initial testimony to Congress was elegantly written, clearly communicating science to policymakers. Tell us a bit how that came about and how your communication style has evolved since.
My communication style was not very. I always felt that I could write reasonably well, but I'm not a speaker, and I think the paper that I wrote that was clearest was in 1981, when I'd started working on climate 5 years earlier, and we wrote this paper in Science in 1981, which we kind of. I've essentially been filling in details on that paper for the last few decades, but I am blunt. That's and I say what I say what I'm thinking, and I don't embellish it. So it.
Do you think you weren't blunt enough 30 years ago?
Well, I think I was blunt enough to get a lot of attention, and then I realized I didn't actually want to continue. Then it gets to be this discussion. You get a lot of reaction, including reaction from scientists who don't agree with everything you say. And so I thought, well, I'm going to go back and just do research. And everybody's good friend, Steve Schneider, was a good friend of mine. He was a student when I was a postdoc. He was a couple of years younger than me. And he is so articulate, and he just loved to do this stuff, to explain it. So I decided after my 1988 and 1989 testimonies, I decided I'm not going to do that anymore, and I'm going to refer them to Steve and to some other scientist. But no, I don't think I'm a communicator, but I think I'm learning to write, and I'm now in the process of writing a book called Sophie's Planet, which consists of a series of letters to my oldest grandchild. And I'm trying, so it forces me to write in a language that a high school student can understand. And I hope that I can make this story clearer, because the public still doesn't really understand the situation. And it's very, very hard to communicate when you're getting all this stuff coming from people who don't want the public to understand. So this is it is a communications problem. We need somebody who can communicate, and I don't know how to do it. I think that the book that I'm working on, I think, is the best I can do. And so I'm going to try to turn down requests for talks like this, which other people can give better than I can anyway, and try to get that book written this year.
You have your own unique communication, and we appreciate it. There are people in the audience from China, from France and other European countries, from Australia, from Africa. What's your message to them, speaking as an American scientist?
Well, I think our best hope for rapid changes lies in China. And amazingly, I've been invited by the U.S. government to go to China in a few weeks. I think if we would cooperate with China, you know, this is a subject which it will be included in my book. I'm writing a paper on it. But, you know, it's really a shame that China is now pouring out this coal pollution, which is not only, if you look at that curve that I showed, things suddenly went like this about 10 or 12 years ago, about a little more than a decade ago, because China started burning coal faster and faster. That was not necessary. We could have developed the next generations of nuclear power, which would have been much safer and much more efficient than the existing ones. But we decided a few decades ago, and I think it was largely because of a quasi-religion that's developed. It's very unscientific around nuclear power. And, you know, in the first State of the Union message of Bill Clinton, he said, we're terminating research, unnecessary research and development in nuclear power. Well, we lost a couple of decades. We could, instead of China building coal plants, they could have had nuclear power and avoided more than 1 million deaths a year from air pollution in China. And the world would have avoided that rapid increase in CO2 emissions. But that's, you know, it's we have to figure out with China what's the way, how can we deal with this? And I think China is ready to have a carbon fee. But that's you can't. The developed world got wealthy off of fossil fuels, so we cannot ask the developing world to give up development. And so there needs to be an alternative to fossil fuels. And the best way to find that and to stop arguing about nuclear power or anything is to put a rising price on carbon and then let the markets decide. Efficiency will be part of the story. Renewable energies will be part of the story, but unlikely to be the whole answer. Again, I keep coming back, singing the same song, but it's got to be this carbon tax or carbon fee.
Our final question. Is there, hopefully there is, a development that is occurring either politically, socially, or scientifically, or technologically that gives you the most optimism for addressing climate change in the foreseeable future?
Well, I mentioned this growing citizens' climate lobby, but in the United States, you know, it's a little scary because of this, the way the politics has become so polarized. So you can have, even if the public decides, for example, with gun control, a majority of the public wanted to see some actions to limit access to guns. But the parties, they don't always respond to what the public wants. But as I've said, I think that China is now going to. They recognize that they are threatened not only by air pollution but by climate change. They have to do something, and if we have the good sense to cooperate with them. As an American, though, I feel very disappointed that we've sort of given up the leadership. But at this point, for the sake of the planet, if it takes China to lead that rescue, that's all right with me. But we still have we have the best universities. We have the best potential for innovations. And those would be spurred if we would just have a market and economy which rewarded them appropriately. But all these bright ideas in California and other places where they're doing things, they won't work as long as fossil fuels are allowed to be dirt cheap and not pay their cost to society.
Ladies and gentlemen, this year's John H. Chafee Memorial Lecture, James Hansen.
Thank you.